Okay, Algebra 2 students, we're still in section 9.1. This would be video number 5 for this section, and so it's part 3, we're calling it, and it is trigonometric ratios. I'm always just going to say trig. I will not be saying trigonometric. So these are all going to be right triangles like we have had so far in 9.1, but for these triangles, something's going to be missing so that we can't use Pythagorean, or we're going to be asked, first of all, our problems are going to look like this, where we're asked to find the trig functions. And then later on, we'll be using the trig functions to find missing angles or missing side lengths. So Pythagorean does not help you find missing angles. The trig functions do help you find missing angles. So there are 6 of the trig functions. Hopefully you remember a little bit of this from geometry. I first want to go over how you say them. So this is sine. It's abbreviated SIN. Cosine is abbreviated COS. Tangent is abbreviated tangent. Now, these are what you might want to call your big 3, your big hitters. They all have a partner that they pair with. So when I say who's sine's partner, I'm talking about this one, which we read it as cosecant, and it's abbreviated CSC. So sine and cosecant are partners. Cosine's partner is secant. Secant is abbreviated SEC. And tangent's partner is cotangent, and it's abbreviated COT. The way you can remember who goes with who, and you do need to remember it, is if you look at a pairing. If I look at sine and cosine, if I look at sine and cosecant, I say the word co over here. So in these pairings, there can only be one co. If I look at this pairing, the co is over here, because this is cosine. So this cannot pair with cosecant, because that's a co. It has to pair with secant. So one co. There's the co. And over here, there can only be one co. So tangent has to pair with cotangent, because there's the co. These two are easy because they look like they go together, right? So cosine has to pair with secant because there can only be one co. And sine has to pair with cosecant because there's the co right there. All right, now the way these are represented is they are the ratio, so they're called ratios. Remember, a ratio is like a fraction, kind of like a numerator and a denominator, a top and a bottom. They are the ratio of the side lengths. So you're going to have a right triangle all the time, and then I would say the first thing you want to identify is the hypotenuse. So the hypotenuse, remember, is always directly across from the right angle. We're going to call the hypotenuse H in this case. This is the angle that we are finding the trig ratios for, theta. So this says sine of theta, cosecant of theta, cosine of theta. So this is our angle. Identify your angle and then draw the little angle symbol like you're used to from geometry. The side that touches your angle is the adjacent side. We're going to label it A. The side that isn't the hypotenuse and doesn't touch your angle is the opposite side, and we're going to call that O. Okay, so hypotenuse is the same for every right triangle. It's directly across from your 90-degree angle. Then, the angle that you're working with, we're always going to be working with a certain angle. If you peek down here at this example, we are finding the trig functions for angle G. So this is what I mean by draw your little angle symbol. Draw your little angle symbol. The side your angle symbol touches is the adjacent. The one opposite the angle that you're working with is the opposite, or the one that doesn't touch it. Okay, now, sine, the trig functions, you will often hear them. You'll hear people say SOHCAHTOA. This is where SOHCAHTOA comes from. Sine is the opposite side over the hypotenuse. So to find the sine of theta, we're going to take the ratio of the opposite side over the hypotenuse. So opposite over hypotenuse. Cosine is adjacent over hypotenuse. So it's going to be the length of the adjacent side over the length of the hypotenuse. And tangent is opposite over adjacent. So opposite over adjacent. So if you peek down here, you're going to have values or side lengths on those sides, and we're going to create that ratio. So that SOHCAHTOA that you'll hear referred to for these trig ratios, this is where it comes from. So is opposite over hypotenuse. Ka is adjacent over hypotenuse, and TOA is opposite over adjacent. Now the nice thing about the partners is it's just the reciprocal. So this would be hypotenuse over opposite. So notice I just took this ratio and I flipped it. This one's going to be hypotenuse over adjacent. I took my ratio for cosine and I took the reciprocal, or I flipped it. So hypotenuse went to the top, adjacent went to the bottom. Tan, the reciprocal of that would be adjacent on the top and opposite on the bottom. Okay? SOHCAHTOA. Now there's some other fun little ways to remember SOHCAHTOA. So here's your SOHCAHTOA here, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. There's some other funny ones to remember it. So if you look at this, saying some old hags can't always hide their age. So there's your sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, TOA, opposite over adjacent. So you can pause the video and take a look at that and find one that you like. Maybe you can use it. Ooh, this one's kind of bad. I shouldn't have that one on there. So yeah, don't use that one. Okay. So let's look at how an example goes here. I'm going to try to keep this so we can still see this. So in this one it says find the 6 trigonometric trig ratios for this triangle. And then I look down here, and in every case I am finding the trig ratio for angle G. So I'm going to put my angle symbol on angle G. Now, one of these sides is going to be the adjacent side, but it's always best to find the hypotenuse first. So here's my right angle. Directly across from my right angle is going to be my hypotenuse. So I'm going to label that H. So this side, because it's touching my angle, is going to be my adjacent side. So I'm going to label that A. The other one, it's got to be opposite. And if you look, it's opposite the angle that we're working with, directly across from it. So now I have my adjacent, hypotenuse, and opposite side, so I can just create my ratio. So I'm going to recopy this just as we're getting used to this. So sine is opposite over hypotenuse, and in this case my opposite side length is 24 and my hypotenuse is 40. So that's it. 24 over 40 is the sine of angle G. I think it's easiest now to do the cosecant, do its partner, because it's just going to be the reciprocal of this. So it's going to be 40 over 24. Cosine is adjacent over hypotenuse, adjacent over hypotenuse. So which side do I have labeled adjacent? This one right here. The side length of my adjacent side is 32. My hypotenuse is 40.